Welcome to the deep dive. Today, we're diving into AI,
Okay.
and specifically a new platform called Cosmos World Foundation Model Platform for Physical AI.
Wow, that's a mouthful.
Yeah, it is a bit, isn't it? But basically, think robots, self-driving cars, and even
Like creating whole worlds with AI.
exactly. We're going to break down how it all works. Our source material today is a pretty detailed research paper.
Okay, so a deep dive then.
Yeah, a real deep dive. So if you're into AI and you want to get up to speed on this Cosmos platform,
This is the place to be.
it is. It really is. So let's start with, well, the heart of it all, World Foundation Models, or WFMs.
Oh, yeah, FMs.
Yeah, WFMs. These are AI models designed to, I guess you could say, understand the physical world.
So not just like recognizing a picture of a cat.
Right, more like predicting how that cat might move, how things interact in the real world. Cosmos WFMs, they're trained on millions of hours of video.
Wow, millions.
Millions, so they can learn.
So it's like giving AI a sense of physics, basically.
Yeah, exactly. Like imagine trying to teach a robot to fold laundry. I mean,
Oh my God.
it would take forever to program every single step, right?
Yeah, that would be a nightmare.
But this is where the pre-trained aspect of Cosmos WFMs comes in.
Pre-trained, so they already know some stuff.
Yeah, they come with a head start. They've already learned basic concepts like how fabric drapes or how gravity works, all from watching those videos, so you don't have to start from scratch.
Oh, that's smart. So it's like building on existing knowledge.
Exactly, and that makes it a lot more efficient. And speaking of efficiency, another key element here is something called tokenization.
Tokenization.
Yeah, think of it like compressing a file on your computer, to make it smaller.
Right, to make it easier to work with.
Yeah, exactly. So Cosmos tokenizes the visual information from videos, breaking it down into these essential elements that AI can process super quickly.
Okay, so it's like simplifying the information.
Yeah, simplifying and organizing it. They've actually developed a few different types of tokenizers. Each one has its own strengths, but
Makes sense. Different tools for different jobs.
right. But the results are incredible. They've managed to tokenize videos like 8 seconds long at high resolution on a single GPU.
Oh, that's impressive.
It is really impressive. But the foundation of all of this, of course, is their video data set. It's massive.
I can imagine. Where do they even get all that video?
Well, they've put a lot of work into building a really high quality database, carefully filtering and annotating the content. They even created this benchmark called ShotBench 2.
Shopbench 2.
Yeah, to test how algorithms handle complex video edits. And they built their own search engine just to find specific video examples.
Wow, so they really went all out.
They did, they had to. Now, when it comes to the models themselves, the actual WFMs, Cosmos uses two main types, diffusion models and autoregressive models.
Two different types, huh? Why not just stick with one?
Well, they each have their own strengths, It's like having different tools in a toolbox.
Okay, so what are the strengths? What are they good at?
Well, diffusion models are fantastic for generating high fidelity, like really realistic videos.
Oh, so like creating those virtual worlds you were talking about.
Yeah, exactly. Or generating special effects for movies. Think lifelike, detailed, visually stunning.
So that's diffusion models. What about the other ones, the autoregressive?
Right, those are a bit different. They're all about speed, super fast responses.
So for tasks where you need like instant reactions.
Exactly, like controlling a robot arm in real time or something like that.
Got it. So one's for quality, the other for speed. Interesting. But how do they know that these models, either type, actually understand the physical world?
That is a great question. And to answer that, they used physics simulations.
Physics simulation.
Yeah, they created these virtual environments with different scenarios, objects falling, rolling, colliding. They even had stacks of objects, like blocks.
To see if they'd topple over.
Yeah, it's like giving the AI a physics exam. They wanted to see if they could predict what would happen.
So like virtual crash tests for AI.
Exactly. But they didn't just look at whether the AI got the pixels right. They evaluated the WFMs on 3 levels: pixel level, feature level, and object level.
Okay, so they were looking for a deep understanding, not just surface details.
Right. They wanted to make sure the AI could recognize individual objects, understand their properties, and predict how they would behave. And that's super important.
Absolutely. Especially if you want to build robots and self-driving cars that can interact with the real world.
Right. And speaking of interacting with the real world, there are some safety concerns that come along with this kind of technology. Cosmos is very aware of that, and they've taken steps to address those potential risks. But we'll dive into that a bit later. First, let's explore those two types of WFMs a little more, Starting with diffusion models. What makes them so good at creating these realistic videos?
Yeah, let's unpack that. It sounds pretty amazing.
It is, and we'll do that right after this. All right, so diffusion models, these are the ones that can create, super realistic videos.
Yeah, how do they do that? It sounds kind of like magic, honestly.
It does a bit, doesn't it? It's a pretty complex process, but imagine
Okay.
imagine restoring a faded photograph, like bringing it back to life.
Okay, I see.
Diffusion models, they start with a noisy, like blurry version of a video, and then step by step,
Yeah.
they refine it. They gradually remove that noise.
So it's like taking a video and then scrambling it all up
Yeah.
and then teaching the AI to put it back together perfectly.
Exactly. That's a great way to put it. Cosmos, they adapted a specific type of diffusion model. It's called DIT. It stands for Denoising Diffusion Implicit Models.
The DIT, huh?
Catchy.
Yeah. Well, you know how these things go. But the results they're getting, really impressive, like
Right.
creating these 3D worlds that you can actually move through, explore.
So like AI that can create video games, basically.
Exactly. Or VR simulations, anything you can imagine. And they're even working on ways to, like, control these models with text prompts.
Whoa, so you could just type in, like, create a forest with a waterfall, and it would just make it. Yeah, that's the idea. It's wild, right? But, okay, let's shift gears for a second and talk about the other type of WFM we mentioned, the autoregressive models. These are all about speed.
Right. Sprinters.
Yeah, the sprinters of the AI world. They work by predicting, basically, the next element in a sequence. So, like, predicting the next word in a sentence. But instead of words, it's the next frame in a video.
Ah, got it. Got it.
And because they work this way, sequentially, they're super fast, perfect for real-time stuff.
Like robot control.
Yeah, exactly. Cosmos uses this technique called Medusa.
Medusa. Sounds intense.
Yeah, it's a cool name, right? But it basically helps the model predict future frames by looking at a smaller, lower resolution version first.
So it's like getting a sneak peek before diving into the full thing.
Yeah, saves a lot of processing time. And get this, it lets these models generate video at like 10 frames per second in real time.
That's crazy. So you could control a robot with that level of responsiveness.
Exactly. Pretty incredible, right? But let's go back to those physics simulations for a minute. The ones Cosmos used to test their models, make sure they understand the physical world.
Right.
They had all sorts of scenarios. Objects falling, rolling, colliding. They even had stacks of blocks, like
Jenga.
yeah, kind of like Jenga, to see if the WFMs could predict when those stacks would topple over based on, their weight and arrangement.
So really putting them to the test.
They were. And remember, they evaluated these models on 3 different levels.
Yeah, the pixel level, feature level, and object level.
Right. So not just did it look right, but did it actually understand what was happening? Did it recognize the objects, their properties, and how they would behave?
That's a lot more thorough than I would have expected.
It's important. You can't have robots running around bumping into things because they don't understand basic physics.
Yeah, no kidding. Safety first.
Exactly. And that brings us to, I guess, the responsibility side of things. All this power comes with, well, some potential risks.
Yeah, you can't just unleash this technology without thinking about the consequences.
Right. Cosmos is very aware of that. They've implemented this, like, 3-layered approach to safety.
Okay, 3 layers. Like a cake.
Yeah, kind of. First layer is keyword blocking. They have this massive list of banned words and phrases, things that would trigger an alert.
So like a first line of defense against, I don't know, creating something harmful or inappropriate.
Yeah, exactly. But of course, language can be tricky, right? People can find ways to say things without using those specific words. So that's where the second layer comes in.
Oh, I see. What?
Image and video classification. Basically, they have another AI system that's trained to recognize, like, potentially unsafe content.
So it's like a content moderator for AI.
Yeah, basically, making sure nothing bad slips through the cracks. But even with all that, someone could still find a way to exploit the system, right? That's where the third layer comes in.
Oh, okay. Getting intense now. What's the third layer?
They have a red team.
A red team. Like in a video game.
Kind of. It's a team of security experts whose job is to, well, try to break the system.
So they're like the bad guys on purpose.
Yeah, but in a good way. They're constantly coming up with creative, like, adversarial ways to test the safety measures.
So they're trying to find the weaknesses before someone else does.
Exactly. It's like ethical hacking, but for AI. And their findings are constantly being fed back into the system, making it stronger.
That's smart. Always stay one step ahead. So with all these safeguards in place, What are some of the real-world applications of this technology, like besides the video game stuff?
Right, right. Well, robotics is a huge area where this could have a big impact.
Robots,
Er,
like doing our chores and stuff.
maybe someday. But think about it. Imagine a robot that can learn new tasks just by watching a human do them, like an apprentice.
That would be amazing. No more complicated programming.
That's the idea. Cosmos is exploring a bunch of different approaches here. One of them is like instruction-based video prediction.
Instruction-based.
Yeah, you give the robot a command like pick up that blue block, and the WFM generates a sequence of actions, like a plan for the robot to follow.
So instead of programming every single move, you're giving it more general instructions, more like how we learn.
Exactly. And because these WFMs have watched so many videos, they already have a sense of, how things work in the real world, physics, object manipulation, all that stuff.
Like they've had years of on-the-job training, basically.
Yeah. And they've actually had some really cool results with this. Folding clothes, cleaning tables, even navigating around obstacles. It's pretty wild.
Wow. So what about more complex stuff, like things that require multiple steps, real planning?
Yeah, they're working on that too. Things like assembling furniture or, I don't know, preparing a meal. Things that we take for granted but are really complex for robots.
Yeah, it takes a lot of thinking.
It does. But remember, these WFMs are designed to simulate the physical world, so they can break down those complex tasks into smaller steps and then use their knowledge of physics to figure out how to do them.
It's like they're learning to think strategically.
They are. And the speed of those autoregressive models we talked about, that comes in handy here too. Robots need to be able to react in real time.
Right, they can't just freeze up if something unexpected happens.
Exactly. Which brings us to another exciting application. Autonomous driving.
Self-driving cars, that's
Mhm.
like the holy grail of AI, right?
It's up there, but it's tough, Navigating the real world is super complex.
Yeah, no kidding. There are so many variables.
Exactly. But Cosmos, they're building these multi-view WFMs. So basically, models that can generate video from multiple camera angles at the same time.
So it's like giving the AI 360-degree vision.
Yeah, exactly. Like a much more complete picture of what's going on. They're using this to train self-driving car algorithms, giving them a realistic virtual world to learn in.
So it's like driver's ed for AI.
Haha, yeah, kind of. But those virtual environments have to be accurate, right?
Yeah.
So Cosmos is focusing heavily on that, making sure the AI learns to drive safely, even in tricky situations.
So they're throwing everything they can at it to make sure it's ready for the real world.
They are. Winding roads, sudden obstacles, you name it. And the results are looking really promising. They're multi-view WFMs. They're showing a high level of accuracy, predicting movements, navigating, avoiding hazards. It's exciting stuff.
It is. But these multi-view WFMs, they could be used for more than just self-driving cars, right?
Absolutely. Think traffic management, city planning, maybe even virtual tourism. The possibilities are huge.
It all comes back to that core idea, huh?
Yeah,
Giving AI a deeper understanding of the physical world.
it does. It's about moving beyond just, recognizing patterns and towards a more intuitive, almost human-like understanding.
It's like AI that can actually think for itself.
It's getting there, and that's what makes Cosmos so fascinating, in my opinion. They're not just building tools, they're building AI that can really interact with the world in a way that we thought was only possible for humans.
It's pretty mind-blowing when you think about it.
It is, and it raises some big questions about, what intelligence really is, what makes us human, but we'll dive into that a bit later.
Okay, looking forward to that. But first, let's wrap up our exploration of these applications. Where should we go next?
So we've covered a lot of ground here talking about Cosmos WFMs.
Yeah, from like the nitty-gritty details to the big picture stuff.
Right. And it's clear that this platform is a pretty big deal for AI.
Oh yeah, definitely. It's
Yeah.
like pushing the boundaries of what we thought was possible.
Exactly. And as we've discussed, it opens up all these crazy possibilities, robots learning by watching us, self-driving cars that can really handle anything.
Creating whole worlds from scratch.
Exactly. And it's all thanks to these WFMs, these models that can actually understand and interact with the physical world.
It's wild.
Yeah.
But we have to remember, with great power comes great responsibility, or however that saying goes.
Right. And Cosmos knows that. That's why they've put so much effort into those safety measures, The keyword blocking, the image and video classification, the red team.
Yeah, it's good to see them taking that seriously.
Yeah.
Because this technology, it can have a huge impact on, well, everything.
It could. And it's important that we all think about the implications of that. Not just the people building it, but everyone.
We need to have those conversations, the ethical ones, about how we use AI, where we draw the lines.
Absolutely. And Cosmos, I think they're setting a good example. They're not just focused on the tech, but also on the responsibility that comes with it.
Yeah, they're being transparent, careful.
Yeah.
Which is important because it's not just about the advancements, it's about our values,
Right. Right.
how we want to shape the future. And that brings up a really interesting question. If AI can now understand the physical world like this, what does that say about our own intelligence?
Whoa, that's deep.
Right. It's like, are we just machines, but more complex? Or is there something more to us? Something that sets us apart?
It's a question philosophers have been asking forever.
They have, but AI makes it even more relevant now. The fact that we can build these machines that can learn, adapt, solve problems, it makes you think.
It makes you wonder what it even means to be intelligent. It does. Maybe by trying to understand artificial intelligence, we'll end up understanding ourselves better.
That's an interesting thought. Like AI is a mirror.
Yeah. So we've reached the end of our deep dive into Cosmos and these WFMs. Hopefully you've learned something new, gotten a sense of what this technology is all about.
It's exciting stuff. And a little bit scary, maybe.
Yeah, a little bit of both. But it's important to be aware of these developments, to keep learning, to ask questions.
Because AI is here to stay.
It is. And it's going to shape the future, whether we like it or not.
So we better be ready for it.
We better be. Thanks for joining us on this deep dive. We'll see you next time.